Welcome back to another tutorial. Today we're going to be looking at moving the player around, having some lanes, so just like this, and we actually swap in between these lanes. This is not perfect, but this is the very first iteration we're going to be doing, and this is a little bit heavy for a very first real episode, you could say, but it is something we have to go through, and if we do it at the beginning, we're going to be able to test our game and actually feel it a lot faster than if we don't do that right now. So guys, after this episode, you're going to have this result you see here on the screen. I hope you enjoyed, and let's actually get right into it. Okay, so we are back in this scene right here. That's the gym scene. We are not going to be using the gym scene in this episode, as we are going to be directly building in our game scene, which is going to be, the one that wraps everything up. So I'm going to go ahead and just leave this one right here. Make sure I hit Control and N to create a new scene, then Control S. And let's actually call this one game scene. So just game like that. We're going to drag and drop it inside of the scene folder. And what I usually like to do is get this skybox off. So I go under Window, Lighting, Settings, and for the skybox material, I actually just turn that off. So put that on nothing right now. We end up with nothing. So that's our fresh game scene we're going to be using. And in today's episode, like we said in the preview, we are going to be playing around with the player. So just moving the player around, just get some basic controls out. This is something we do every time we create a new series here. So we're going to get started right away by drag and dropping our prefab, so our player prefab, right in the middle of the scene. Let's make sure it is centered, so 0, 0, 0. And then we have this guy right here. The first thing we'll need is to put the animator in there. So we created a state machine for this character. Let's use it right here, and we're going to be playing around with it quite a lot in our control script. But for now, we actually need that control script, so let's hit Add Component, and we are going to create a player motor. This is something we actually do that quite often with every single series we do. We create motor, and those one stands for anything that is movement driven. Alright, so I've got MonoDevelop open right here with our fresh new script. And we're going to start declaring some of the field we are going to need. So I'm just going to put a small comment right here, and just below that we're going to go ahead and create some private field. So I'll be using a private float jump force just to know how high we can actually jump. 6 meters might be a little bit too much. Let's go with 4. Of course, all of that tweaking can be done a little bit later on as we test out our game basically. So we need another float for the gravity. I like to put my gravity at something like 12. Another private float for the vertical velocity. So vertical velocity. And this one we don't actually set it here. It's going to be set every single frame. And then we'll use another float for the speed. And that's about it. So actually we're going to need more than that. But for right now, for only the basic stuff, that's all we need. And if you've been around the channel, you are starting to know these names. We keep using the same exact naming for every time we do a controller. So this one is fairly similar to all the other one we've done. Let's start in the private void start. Of course, we are going to need a character controller. I totally forgot about this one. Let's go ahead and add a character controller at the top right here. And in the start, I'll say controller is equal to get component type of character controller. Which also means if we save all of this real quick, let's go back on our player. It also means that this guy needs a character controller component. So let's actually add it right here and make sure it fits. So obviously this is not going to work. Since our pivot point is at the bottom right here, the capsule is totally not centered. What I like to do is just say you're going to go 1 meter high like this, and then we can play around with the radius and also the height. I'm not quite sure how tall this Pingu is. Let's say it's probably something like 1.6 or 1.5. And then let's just play around with the center. This sounds fair. Now it needs a very, very small radius. And just like that, we should actually be fine. Now, of course, the head is a little bit too high. We are going to need to reduce that because we're going to be playing around with the sliding beneath objects. So put that on 1 just to be safe. Put the height on 1, and then we can go back here and actually put half of the height in the Y. This way we get a really nice capsule just wrapping all around our character motor. Alright, so now that this is completed, I'm going to click off my character controller, go back inside of the script, and let's go down in the update. So private void update. Alright, so now at this point we're in the update loop. We need to know what kind of input our player is giving us. Now in the final game we're going to have mobile input, so you're either going to swipe left, you're either going to swipe right, swipe up. All those directions are going to do actually going to influence your player. But the mobile input is actually quite a big module that we'll be implementing in the next episode, not this one. But as for now, we're only going to be using keyboard touches. So simple stuff. Since we only want to get the player movement out of the way for now, that's what we're going to be doing right here. But of course, we'll come back and we'll implement the swipe inputs quite soon. So before we do anything right here, I'm actually going to create another field actually at the top. So this field is actually going to be used to know which lane am I supposed to be on right now. As you know, in the Subway Surfer, you have 3 lanes, one in the center, one on the left, one on the right. You need to know exactly on which one you should be right now, so I'll be using a simple int to know that. I'll call this private int desired lane, and by default it's going to be on the 1, because it's simply going to go like this. So 0 is left, 1 is middle, so we always start in the middle, and 2 is going to be right. So that's the simple formula we're going to be using for the lanes. Alright, so now we're going to go back down here in the private void update, and what we're going to do is check, are we clicking are we pressing on left or are we pressing on right? So if, let's do input get keyboard or get key down, and we'll use key code left. Do we just have left? Yeah, we do have left arrow right here. So if we're pressing on left, then we're going to do something like move left. Now if we press on right, same thing, we do move right. So let me just write that real quick. And right now I'm using comments, but obviously that's not going to work in the end. So what I wanted to do for this is simply create another function so we don't get confused with, we don't have too much stuff inside of the update. So let's take our function, replace it right here, move lane, and then it's asking us, are we going right? In that case, we're going left, so no, that's a false. And down here, are we going right? That is true. So if we press left, then we call this with the false, and if we press right, then we are calling this with true. Okay, so having that logic done right here, we can start looking at which lane we should be on. So assuming we're going left, so if going right is false, then if that's the case, let's do desired lane minus minus, and now if desired lane is equal to -1, that means we went a little bit too far, and we have to say desired lane is equal to 0, so we basically clamp it. Now same thing down here with the else statement, so desired lane plus plus, and if it is desired lane is equal to 3, that means we went too far, and we say desired lane is equal to 2. Now I just realized that you could have wrapped all of this into few lines, so let's go ahead and try to just rewrite this real quick. So we're going to do desired lane is going to plus equal, and if we are going right, we're going to say plus equal -1, and if we're going if we're going right, it's going to do 1, and if we're going left, then it's going to be -1. And then we can actually access the mathf library. So we say desired lane is equal to mathf, and we can actually clamp using this. So we're going to clamp the same exact value, desired lane again, and the smallest value you can have is 0, the highest value you can have is 2. So here we go, we just put that under 2 lines. Could have kept the one we had before, it doesn't really matter. But we just optimize this a little bit. And let's keep going in our update. So we know which lane we should be on right now when we press. Alright, just to clear things up a little bit, we're going to put some comments up here. So these lines right here are just to gather the input on where we should be, or which lane we should be. And then we'll keep on writing, and over here, let's actually calculate where we should be in the future. So we're gonna have like a little buffer of where we should be. So to do this, we are going to create a vector 3 called target position. Now this target position has to be exactly where we want to go next. So what we'll do right here is say we're going to start with a vector3.forward because we always want to go forward at all times. It's always going to be, say, our current position plus 1 meter in front. Actually, you know what? Let's add it right here. Let's do transform.position.z plus vector3.forward. So, is that going to work? Oh, sorry, it's the times. Alright, let's actually take a quick look at this. We are taking transform.position.z and then we're multiplying it by the forward axis. So basically, we're only going to be taking the z of the player. That's what it means right here. And then we're multiplying by the vector.forward just to have, basically, this is only to have a vector out of this. So it's going to be 0, 0, and then the position and z of the player. So once we have this, now we need to know which lane should he be on. We'll do a switch case. So switch desired lane. Actually, you know what? Let's not do a switch case because it's too small to be into a switch case and it might confuse some of you. So instead we're going to do if desired lane is equal to 0. So if it's equal to 0, target position is going to be plus equal to vector3.left times, and here we'll need the lane distance. Now, I don't know how much space we should leave in between the lanes. We'll get into that quite soon. Until then, let's just make sure that you type in a constant like this and we'll go declare it at the top in a second. So, in case we're not on desired lane 0, we'll do else if desired lane is equal to 1, and if it's equal to 1, we'll do same exact thing, but we'll do plus equals 0. That doesn't actually make sense, does it? It actually doesn't make sense at all. So here's what we'll do instead. We'll just do else if desired lane is equal to 2. Now, if desired lane is equal to 2, plus equal vector3 dot right times lane distance. Else, we really don't have to do anything if we're not on any of those lanes. Now, quickly, let's take this, copy it, head over to the top, and I'll just declare a private const float line distance. Say it's going to be 3 meters. I got to make sure that it's actually 3 meters because the assets, I think, are 3 meters in length. So whatever the size of the assets are is what I need to put there so we can stack them perfectly. Alright, so at this point we know which lane we should be on. We know where exactly we should be. Now let's start calculating our move vector. So how are we going to get there from where we are right now? So let's calculate our move vector. That's basically our move delta, you could call it. We like to call ours move vector, that's why I called it like that, and we always initiate it to vector3.0. Then after that, let's go ahead and add some parameters to that. So how are we going to find the x of it? So how do we know how far we need to move in x to get closer to our target position? To do this, I'll do a move vector.x is equal to, let's take the target position minus the transform position. We'll normalize it just to get a unitary vector. Then we'll do .x times speed. Okay, so this might sound complicated, but basically what we do is we take where we should be minus where we are right now, which is going to give us a it's basically going to give us like a directional vector on where we need to go to get there. Then we normalize it to make sure it's only based off a single meter. We take the .x of that meter and then we multiply it by speed. Alright, so next up we have the move vector.y, and for the y, we don't have the whole gravity system implemented just yet, so we'll just do something like minus 0.1, so we're always sticking to the floor. Just for now, of course, we'll have the whole gravity system implemented quite soon. On the next step, we have to do the z. Now, the z is very simple, as we always move forward, so move vector.z is going to equal to speed. Alright, so once all of this is completed, let's go ahead and move the pengu. And to move the pengu, controller.move, we move using the move vector times time.delta time. Always make sure you do a times time.delta time. This way, your thing actually runs on the same speed, no matter what the frame rate is. So even if you're super laggy or you have a super very well performing phone, then it's always going to go on the same speed on both CPUs. Or on both machines. Okay, so having that done, let's actually play this, see what happens. We have this Pingu, and he is falling. He's falling and he's moving ahead. So basically we have the small movement we said right here, the minus 0.1 every second in a Y. You're going to see him go down a little bit. You can tell by looking at the Y right here, and he's also going forward. So that is our movement for now. Now if we press left or right, do we get anything? We don't seem to get anything. Oh, actually, sorry, we do. I was just not pressing on the right ones. Alright, so make sure you go ahead and you save the player prefab. We're going to need him, well, pretty much the whole game. And something I'd like to do just before we actually move on to anything else, I'd like to actually test this out, because we're really test driven here. We keep doing code, but we like to test it a lot more for some reason. We are going to go ahead and just create a new plane object. I'll be centering it in the world, maybe make it 3, 0.25. How much place do we need? Let's go ahead and do 0.33. So a third of the size. I think that covers our lane. And then in terms of the z-axis, we're going to put that on something crazy like 1,000. Then we can have a look at our Pengu as he goes. And let's see, so I can go left, right. Obviously this plane is not big enough, but that looks pretty good in terms of lane for now. Let's go ahead and just make this plane a little bit bigger. Actually a lot bigger. And this is better to see him. Okay. Next step, we are going to look at the camera. So we're going to create the camera as well in this episode, so this way we don't actually lose our player in the far away. So to do this, create a script. I'm simply going to create C# script, and that's going to be, you probably guessed it, camera motor. This one is going to be fairly simple to understand and also very simple to write. Let's double click on it. And just to mention it real quick, we are definitely not done with the player motor. The player controls are not smooth enough, they're not, balanced, all that kind of stuff, so we'll have to come back there quite often in the next few episodes. But let's quickly do the camera motor, because this one is very easy. So this one is fairly simple. We start with a nice public transform lookat, which is obviously going to be our Pengu, so our Pengu / object we're looking at. Next up we have the public vector3 offset that we're simply going to be using to have a distance in between our player and also the camera. So in terms of the x-axis, we never move on the x-axis in the Subway Surfer. It always stays still right there on the x-axis. For the y, we're going to give ourselves 5 meters up. Of course, we can modify that. And for the distance in between the camera and the player, let's do something like 10 meters. And now here is what we need. We need a private void late update. Don't forget, this is not an update, this is a late update, because we got to make sure that the player moves first before we move the camera. This way we don't have any glitter. We do a desired position, just to add a little smooth. Desired position, actually, you know what? What we would do is simply something like transform.position is equal to lookat.position plus offset, and this would work just fine. But since we want to have some kind of smoothing, we like having some smoothing in here, we'll do a vector3 desired position instead is equal to lookat position plus offset. So this is where we should be, and now we'll do desired position dot x is going to be equal to 0, since of course we don't want to actually use the player's position. We always want to be sitting still on 0 in terms of x. And then we can do something like we do a vector3 dot lerp in between our current position and then where we should be, so desired position. Does that work? Yeah, we need the last, time.delta time could be a good one. Okay, so we can test this out, see if it actually looks good. I'll be taking my camera over here, putting the script on it, so camera motor, and we're going to drag and drop the player right in there, press play, and see what we can actually do with this thing. So you're going to see that there is some kind of smoothing at the beginning. That's totally normal. That's because of the camera not being set on the initial value it should be on, so we might want to be modifying that right now actually. Let's say we add a start, so private void start, and we'll say transform.position is equal to lookat.position plus offset. So when the game starts, there's no like smoothing from here to pretty much just there. It's going to be snapping instantly. Alright, with the split screen just like that, I am going to go ahead and test this out. So let's press play. and we see that our camera is following the penguin. Now if I go left, it stays right there, so it hasn't moved on the x-axis, it actually stays right there. We have the basic control right here for the Subway Surfer. Now of course our penguin is a little bit stupid, it just keeps doing all the animation in loops. Before we actually close this episode, let's go ahead and make sure he only does the running for now, of course. I'm going to click on player, go under Animator, double click on player again, and this way we can modify this right here to make sure we always just run. So, oops, let's not remove any animation. I'm only going to remove the links in between them and make sure that run is actually my default one. At this point, if I go ahead and I play the game, you're going to see that we just follow our penguin around when he's running. Now, I don't really like distance we have at the moment. It's a little bit too heavy, so I'm going to go under player motor, the camera motor. Say we only want to be like 2.5 meter up and say -5 in Z. I just modified those. Looks a little bit better. Maybe we want to play around with this offset so we're closer. So what about -2? It's actually really hard to tell right now because we have some kind of smoothing going on. But if I do -2, this is actually not bad. Alright, so I'm going to be using 0, 2.5 and -2 for the offset on the camera. Alright, so this is where we'll conclude the very first heavy episode of the Subway Skater. There's going to be some lighter one, there's going to be some longer one of course. But this is what we have at the moment. It is a running Pingu, and I hope you guys enjoy. I hope you liked it. If you did, please leave a like on the video, check out the Facebook page, the Patreon, all that kind of stuff, and make sure you click on this video right here that appears on the screen to go to the next one, in which we'll learn about gravity and possibly mobile inputs. Alright guys, so thank you so much for watching, and I'll catch you in the next one.